Our lesson for today will be looking at chemistry 1502. The topic for today is alcohol reactions. We will be looking at oxidation of alcohols. Lesson 102. Let us start. In acid catalyzed reactions of alcohols, I did mention that the lesson series will go as follows. We have lesson 101, 101.1, 101.2. It simply means that the lesson series of 1.1, they're based on acid catalyzed dehydration of alcohols, and then lesson 102 simply means that it's a new reaction. Like, for example, now we are dealing with oxidation, so this simply means that this is the first lesson video based on oxidation. Don't be confused to say that it starts with lesson 101, but instead lesson 102 is the first lesson video based on oxidation of alcohol. Then it simply means that the next lesson video based on the very same reaction will be lesson 102.1. So just a quick review. Remember that whenever we take an alcohol, it doesn't matter whether it is primary, secondary, or tertiary, and then we dehydrate it, we know that a functional group that will be yielded, it will be an alkene. That one, we actually did it. And then when it comes to the oxidation, what you should know is that whenever we take an alcohol and then it undergoes oxidation, you should know that we are going to have three possibilities. The first one might be a ketone. I believe you've watched the lesson video based on a functional group, which is a ketone, or an aldehyde. Also, there is a lesson video explaining this in detail, or a carboxylic acid. So whenever you take an alcohol and it undergoes oxidation, you should know that one of the three possibilities will actually occur. So it depends on the type of alcohol we have to yield a particular functional group. So today we'll be looking at the basics of oxidation. Remember that the main challenge for students to master a certain concept is that if they don't have enough basics or solid basics, it will be difficult to look at more challenging questions. So in this lesson video, we'll be looking at the introduction of oxidation. Now, this is the first thing that you should know. You should write down and take note of. Now, let us start with the last two outcomes. How do we go about to get an aldehyde or a carboxylic acid? Just a quick review. Remember that we have different types of alcohols. We have primary, secondary, and tertiary alcohols. Now, looking at a primary alcohol, we are looking at a compound whereby the hydroxy group is directly attached to a carbon or carbonyl carbon, which is also bonded to one other carbon, meaning that if we have our hydroxy group here, this is the carbon which is bonded to the hydroxy group. It's also bonded to only one other carbon. So this will be our primary alcohol. Then looking at a secondary alcohol, we look at a carbonyl carbon, or the carbon which is bonded to hydroxy group must be bonded to two other carbons. So if we have something like this, this will refer it to a secondary alcohol. Then for a tertiary alcohol, we have a carbon which is bonded to the hydroxy group. It's also bonded to other 3 carbons. You should put a methyl here. Then here we have our hydroxy group. This is something of which you've learned in the lesson series based on the functional group alcohols. Now the type of the outcome that we have after a oxidation reaction, it fully depends on the type of alcohol we have. So each type of alcohol we have here will yield a different functional group. So let us start with the primary alcohol. When we oxidize a primary alcohol, you should know that, well, this OX, it simply represents an oxidant. So when we oxidize a primary alcohol, you should know that we always yield a aldehyde. Remember that aldehyde is a carbonyl group with a double bond to oxygen and having hydrogen here. One of the important things that you should note, whenever we oxidize a primary alcohol, we always yield a aldehyde. And then we can further oxidize an aldehyde to form carboxylic acids. So primary alcohols, you should know that they yield aldehyde, and then when we continue to oxidize aldehydes, we form carboxylic acids. So whenever you think about primary alcohols, think about aldehydes and carboxylic acids. But you should also note that we can oxidize a primary alcohol straight to carboxylic acids. It fully depends on the type of oxidant reagent that we use. We will get to that in a moment. Now let us go to secondary alcohols. You should know that whenever we oxidize a secondary alcohol, we yield a functional group that contains a carbonyl group, which is ketones. So whenever we oxidize a secondary alcohol, you should know that we yield ketones. That is always the case. When we go to tertiary, alcohols, you should understand this. Whenever we oxidize a tertiary alcohol, you should know that there won't be any reaction. Remember that in this lesson video we are not talking about the mechanism, but we can explain this using a mechanism. So for now, what is important, you should know that tertiary alcohols, they don't go oxidation. There are important things that you should know about oxidation of alcohols. The main basic mechanism of oxidation, you should know that what we do, we add the oxygens and remove, or there's a loss of hydrogen atoms. So what we do, we simply add oxygens and we remove hydrogen atoms. And we should also note that for the aldehydes, we only introduce one atom of oxygen. Then what we normally do, we remove two hydrogens from an alcohol. You should know that one of the hydrogens should be on the carbon itself, and then the second hydrogen is from the hydroxy group. In that way, we form a carbonyl group. Let us look at a practical example. Suppose we have this. Let's actually use ethanol. So if this primary alcohol undergoes oxidation, what happens is that we have to look at the hydrogen from the hydroxy group, which is this one, and also take one of the hydrogens from the very same carbon that is attached to the hydroxy group. Then you can clearly see that we have removed two hydrogens, and then we will have an aldehyde, which we have double bond here and hydrogen. This hydrogen is the one that is left here. Then you can see that we have removed two hydrogens. We oxidize this further, meaning that we take the aldehyde, we oxidize it to form a carboxylic acid. I want you to look at the transition, the difference between the two, or what actually transpired in order to get a carboxylic acid. What happened is that we removed this hydrogen and replaced it with this hydroxy group, but remember this is carboxylic acid. It falls under carboxyl group. And like I said, one other thing which is very important, remember that we can go from a primary alcohol and go straight to carboxylic acid. It all depends on the type of oxidants we have. Well, let us look at oxidation of a secondary alcohol. In this one, remember that the basic mechanism, we remove one hydrogen from hydroxy group and the second hydrogen from the very same carbonyl carbon. So we are going to take out this and also this, and then this will form a ketone. It doesn't matter whether we use actually any type of oxidant reagent will oxidize a secondary alcohol to a ketone. Now let us look at a tertiary. Why do we say there's no reaction? An example of a tertiary It's something like this. And then we have our hydroxy group here. Remember, we said the basic mechanism is that we have to remove hydrogen atoms. So looking at this carbon, this one, you can see that it doesn't have any hydrogens to remove. We are not talking about this one. Remember that we have to remove one from hydroxy group and one from the carbon, the very same carbon which is bonded to the hydroxy group. So in this case, you can see that we don't have any hydrogen to remove from the very same carbon. That is why we say it is not easy to oxidize a tertiary alcohol. In the next lesson video, which is lesson 102.1 of oxidation of alcohols, we'll be looking at different types of oxidants, meaning that if it happens that you are given a question and then you'd like to know the major product or the product formed, we look at the type of oxidant, especially when we are dealing with a primary alcohol, in order to determine whether we are going to have an aldehyde as our product or carboxylic acid. We have to look at the type of oxidant reagent we have. So in the next lesson video, we'll be discussing those reagents in order for us to be able to determine the type of functional group we are going to yield when we oxidize a primary alcohol. That's it for this lesson video. This is Wahula SJ. Thank you very much.